Uh, my name is Meijer. I'm a freelance game developer who started using Unity about 6 months ago, 7 months ago. Um, I come from the macromedia director world. I'm glad that I finally have access to a nicer 3D engine. I work together with a company called ArtPlant, and we've been making games for the last 5 years using Director. So moving into Unity has been really nice, but it also has forced us to change the way we work a little bit and change. Basically, we needed to just relearn and rediscover a whole bunch of stuff. And in this talk, I'll talk about the things that we learned so that you won't have to go through the same lengthy process as we did, assuming you didn't already do that. We are currently working on a MMO game that we're doing together with Funcom. I'll use that game as a sort of showcase project that illustrates the various problems that we have run into, mainly on the asset importing side. And I'll walk through the different problems we faced and the different strategies for solving them. I'll start with a very quick demo of a current prototype of the game. Miguel, could you be so kind to log in? There we go. I'll start the server here. So it's an MMO game. The client of the game is built on top of Unity 3D. The server of the game we build on Mono. You ready to connect, Miguel? Oh, you're there? Okay, so if you go in first, this is a prototype character selection screen. We have this girl and this guy that you can choose from. There's some texture customizations that you can do, and item customizations. We can, if I turn these all off, we sort of start off with a base mesh. Excuse the nudity. So this is a base mesh, and we have a lot of texture layers that we put on top that we composite at runtime. So we can put stuff like this on, and then have some leather stuff. You can see that as I put on texture layers, it's not only the diffuse map that changes, but also the normal map. I think it shows especially well on this one. So we modify the diffuse map and the normal map and the specular map at runtime by compositing these different layers. And then on top of that, we have regular skin meshes that we can put in. Miguel, did you pick the girl or the guy? But do you have the guy or the girl? Okay, I'll take the guy then. Kick your ass. Okay, so can you walk around a bit? It's a turn-based game, so I'm just gonna. Yeah, but you timed out. Okay, so we're just gonna kill this guy in the left bottom here. That's Miguel. Oh, we might actually hit a bug here. Can you still? Can you still move, or are you dead? Okay, so throw in a few final blows. Kill him off. Oh. Yeah, I'll get you later. Yeah. Okay, so while developing this, we've ran into all sorts of difficulty with regards to getting our assets in. The first thing I actually want to talk about is how to set up a productive work environment. Like, what text editor do you use? Do you have a Mac or a PC or both?
Can I have a show of hands? Who uses the Unitron editor? I don't believe it. Only 15 guys? Like what other editors are popular? Like, is TextMate? I heard TextMate a few times. Visual Studio. Anything else that we're missing? Yeah? Komodo. Okay, so I am a big fan of Visual Studio. I think the tools that Visual Studio has to help you learn Unity are so powerful that it makes very little sense not to use it, assuming you use C# for all your scripting, which I also think is a very good idea. You can run Visual Studio either on a separate PC, and you can use a program called Synergy 2 to have your Mac mouse move over to your PC and back so that it sort of feels like a second monitor. That's actually what I do in my work setup. But for the presentation, I only have one screen, so I'm actually running Visual Studio in a virtual machine. So this is Visual Studio, the Windows version, which only runs on Windows. Running on my Mac in VMware Fusion. It, ironically enough, has a feature called Unity, which lets you sort of extract Windows programs out of the virtual machine. And I'd like to just quickly illustrate a few of the features that Visual Studio has that allow you to just do stuff a lot more faster. Does anybody know the API for building a player by script from their head? That's what I thought. Neither do I. So normally you look it up in the help, which if you have to do it so many times a day, just takes an unbelievable amount of time. If you use it in Visual Studio, you can just say, if you remember it starts with a B, you could say, oh, build, what was it? It was build pipeline, right? Then you do a dot. It shows you all the possible options. It says, oh, right, it's build player. And then if you forgot the arguments, you just do an opening parenthesis, and it tells you, okay, the first argument's the levels, second one is the location name. So it helps you not have to reach to the Unity help for every little thing you do. Like, was it called build player or build web player? Were the arguments like this or like that? I keep forgetting that all the time, and just having the Visual Studio IntelliSense tell it to you is really helpful, especially when I was learning the Unity API. It's just really nice if you want to just discover what you can do. If you have a game object geo, that you could just go geo dot, and then you can see all the stuff you can do with it. Other cool features of Visual Studio is that you can actually have quite powerful refactoring tools. For instance, if these are, by the way, all the scripts that we've used in the game and also in the server. If I go, for instance, here, that's not a good example. If I would go, let's say here in Subversion Management, I could, for instance, rename this method. Or let's say I could say refactor this thing, rename it, and then using the knowledge of the compiler, I can say, well, this shouldn't be set get GUID for file, this should be hello. And using the knowledge of the compiler, it will actually go through your entire project and change all those identifiers to your new name. With the knowledge of the actual C# language. So it's a lot more powerful than find and replace, because find and replace would go through all your comments, or maybe there's another name that has that name in it, and then you mess that up, or maybe you forget one. If you do it like this, you never forget one, and it shows you all it previews the changes that it wants to do for you, and then you just say, okay. So I think these features are so essential to being productive from a day-to-day basis that I wanted to start off the talk with that. It's a bit tricky to use Visual Studio because like all your Unity scripts are in your Unity project folder, and then when you make a Visual Studio solution, all those scripts are in the Visual Studio thing. So I've noticed a lot of people are struggling. Like, do you sort of put the scripts in there and then copy them over manually, or do you compile stuff into DLL and then bring the DLL into Unity? The way that I find to work really well is to use a symbolic link trick. So if I open a new project, Visual Studio project. And oops, I'll create a folder called scripts here. And then in Visual Studio, I create a new solution, but I make sure I create the solution on my Mac share. So my Macintosh has a share that the Windows machine is logged into, and I make sure to put the Visual Studio solution on the Macintosh share, because the Macintosh file system supports symbolic links and the Windows file system only has, it has some sort of symbolic links, but they don't really work just as well. So VS example, don't need this. When you're in Visual Studio, you create a folder in Visual Studio as well. You name it scripts. Then you close Visual Studio, and I save it. The Z is the map network drive that maps to my Mac. And then on the Mac again, where did I put this stuff? It's in, you know. I go to VS Project. Oh no, that's the thing. I put it here. Does anybody remember how I called the Visual Studio thing? VS example, here we are. So you CD into that, you remove the scripts folder, and then you make a symbolic link. Oh. You make a symbolic link from the assets folder in Unity. Assets scripts. Oh, it's getting a bit too big here. And you link it to the scripts. You make a symbolic link here. It ends up looking like this. So now Visual Studio will think that this is still its regular script folder, but it actually points to the script folder in your Unity project. And if I now use Visual Studio, where's my Visual Studio? Oh, I closed it, of course. If I now reopen the solution, I can make a script inside that folder. Let's use a regular code file. You can actually set all these default things up to have all your Unity stuff. You could make like mono behavior templates so that you don't have to write the same code all over again. I never got around to actually doing that. And you could do stuff like using Unity engine. And I'm not going to write it any further, but you'll see that in Unity, that script actually appears. So now your Visual Studio stuff and your Unity stuff is looking at this. Is looking at the same folder. You can actually use the Visual Studio compiler to compile your Unity scripts, not with the purpose of actually running the result of that compilation, but just to check if you have any compilers. And then if you double-click on the compiler in Visual Studio, it will actually let you go back. It brings you to the correct line automatically. The only thing you need to do as well is add references to the to Visual Studio. You need to go into the solution, say add reference, and here you actually need to place two files. It's Unity engine.dll and Unity editor.dll. And if you add those, then you'll make Visual Studio aware of the Unity namespaces. There's a friendly guy on the forum named Ben Blow, I think, who actually parsed, there he is, who actually parsed all the HTML stuff from the official help and made like Visual Studio compatible XML stuff that you can add in that as well. And if you do that, then if you get the pop-ups with the IntelliSense, it actually has the Unity help in there as well. Maybe one day the Unity folks will provide the XML Visual Studio stuff from their automatic help compilation stuff, and you don't have to do it anymore. But until that time, I thank you very much. Okay, so that's a story on Visual Studio. The rest of my talk is mostly about the asset pipeline, and I'll start off with actually with sort of me sharing my realization of what assets actually are and how the import process actually works. It took a while for me actually to realize that. Joe told me like 10 times, and I was like, yeah, and then only like a few months later I was like, ah. So I'm hoping I can explain that here. Okay, so when you put a image file in your assets folder in Unity, Unity will read that image file. It knows, okay, this is an image file, so I should make a texture out of it. It reads the image file, it creates an instance of the actual texture 2D class, and then it saves that texture instance to disk. It stores it in your cache folder, in the library folder, I believe. So with textures, it's relatively easily. If you put in a WAV file, this is a WAV file, Unity will recognize, hey, this is a WAV file. I know from WAV file I should make audio clips. So it generates an instance of Unity engine.audioclip and actually saves that to disk. So those are two really easy asset types. It gets more complicated when you get into models and FBXs. For instance, the thing I have selected now, how would you call that? Like, anybody? Okay, who thinks would be an FBX? Nobody thinks this is an FBX? I would say it's an FBX. I mean, I put an FBX file in the assets folder. It turns into this sort of geometry icon. But you could also say that it's actually a game object. So the project window is a bit of a strange thing because it looks like it displays the file system in your assets folder, but in fact it also displays the thing that Unity generates from the assets in your assets folder. For instance, if I have this thing selected, this is a game object. It contains an animation component, and this is a game object, this is a game object. This is all stuff that Unity generated while parsing my FBX file. And it took me a long time to realize that when Unity does that, they actually generate instances of Unity engine.gameObject, and it creates an instance of an animation component, and it generates instances of all those, and they're really not that different from game objects living, for instance, in your scene. It's actually sort of the same thing. The difference is that the one in your scene actually lives in your scene file, and these ones in your assets folder, they live in your cache folder. Now, so we have image import, sound import, FBX import. There's a few more, I guess. Unfortunately, there is no way yet that you can add your own types of importers in that. I would, for instance, love to have a Photoshop importer that doesn't import things as a flat texture, but actually imports things as a series of textures with one for each layer and maybe with metadata and everything on it. However, although it's unfortunate that we cannot make our own, the FBX importer has been introduced a lot of hooks since Unity 2.1 that actually let you mold and modify the way Unity parses your FBX file. Actually, Unity parses your FBX file, then it generates this whole set of game objects and components and mesh filters and animation clips. And before it saves it to disk, it actually gives your editor script a chance to change it. for instance, I'll show the project that I demoed in a bit. This is one of the animation that comes from that. We have like the guy has maybe, I don't know, like 50 or 60 animations now, and that's only for like 1 or 2 weapons. Those animated, we'll probably have like 200 or something animations per character, and we'll have a multiple characters. So it's a lot of stuff, and we use 1 FBX per animation. So actually all this stuff, we really don't want it. We're only interested in this take 001 thing, which is the actual animation data that's stored in this thing. I'll quickly show this thing to give you some context of the thing we're looking at. So this is just the animation for a character. And all the actual geometry info and the mesh filters and the materials that got generated from it, we really don't care. We only care about this thing, the take 001. And even that thing is incorrectly named for us. It's the way the motion builder exports, or it's the art team forgetting to rename the default name. So what we actually want to do is we want to kill all that stuff, rename the animation clip to the name of the original FBX file, and then use that. And since Unity 2.1, we can actually do that. If I'll open the project that I demoed just earlier, notice that this animation was called none-run. And I have that same FBX file in this project. Okay, so these are the animations for this dude. Now we have none-run over here. And you can see that all the crap is gone, and the animation clip is now called none-run. If I go to Visual Studio and see how that, show you how that actually happens. So we have an editor script called Animation FBX Cleaner. It implements Acid Post-Processor. And Unity sends us a call on post-process model. And then as argument, it gives you a game object. Now this happens, I put a FBX in my assets folder. Unity parses the FBX. Unity generates game objects, mesh filters, animation clips. I think that's about it. Skin mesh renderers, their components. And as it is about to write that to disk as the permanent result of your import, it actually gives you a chance to mess around with it. So what we do is we check if the path of the FBX file that was imported, if it has the word animation in it. That's sort of a convention for us that dictates that everything in there is an animation and should be treated as one. And then we iterate through all the transforms in that root.transform, which is the argument we got from the Unity call. We put them all in a list, and then later we iterate through the list and we nuke them all. The reason we put them in a list first and then nuke them is if you delete stuff from a list you're iterating over, your stuff gets more complicated than you want it to. Then here we actually are able to change the name of the animation clip that was imported as well. And the good thing is that I'll talk about more import hooks later, but in all these import hooks you actually have the full knowledge of everything that is in your asset database, and you can use that knowledge to determine how different stuff gets imported. There's something else here. If you looked at the none-run animation that I showed before, you saw one game object that was called distance is 3.37. That is metadata about the run animation. It tells us that in one walk cycle how much the character should move forward. We could have put that data inside Unity, but if you took a look at the list of animations we have, it's just a pain in the ass management-wise. It's really metadata about the animations, so we like to store it in Motion Builder or in 3D Studio Max. I'm actually not sure what they're using these days. So what we do is I tell them, okay, you make a dummy thing, model-y thing in your scene, and you just call it distance is 3.37. And here, as I import that, I'm looking for any game object that has the equal sign. And everything before the equal sign, I put in a dictionary as the key, and everything after the equal sign, I put in a dictionary as the value. So that's a way that the art team can include metadata in this case, animations. And this is the way that you as a Unity programmer can actually extract that information and convert it into a way that actually makes sense for Unity to use. Going a bit further on that, if you look at the way the non-run gets imported over here, you can see that there's a new thing here called the animation clip wrapper. This is just a component that I wrote myself. I'll open the keys and the values. You can see that I'm currently storing these things as strings, the distance key and the distance value, and it contains a reference to the actual animation clip. So now instead of dragging really like these animation clips around, we drag these animation clipper wrappers around that not only have a reference to the actual animation data, but that also contain all the metadata that the art team has put into Max. This is possible because we get a chance to modify the way the FBX importer works. So this component, this wasn't there when Unity did the FBX import. When Unity gave me the opportunity to actually modify how it got imported over here, I actually make a new game object that I make a child of that root game object that got imported, and I add my own custom component to that. So you could go totally nuts with this, which we actually do in some places, and you can really mold the way the Unity imports your stuff into a way that makes sense for your specific game. This import, this trick of modifying the stuff as it gets imported is also extremely useful if you're dealing with scenes that have light maps. Is one over here. If you look at this scene is maybe, I think, 7 or 8 or 10 or something objects. We have diffuse textures everywhere, and then we have light maps, and we have one light map per object. For some reason that maybe, hopefully somebody can finally explain to me, 3D Studio Max and most other light mappers that we've been looking at can only make one light map per object and cannot say, okay, take these 4 objects and make one light map for all of them. So for each of these objects here, we have a separate light map. So if we take a look at this thing, it's called Dungeon Walls. And if you look at how we organize our materials and textures over here, we'll have a Dungeons Walls lighting map. Now that's all nice and all, but it actually gets you in trouble when you have say a material of wood or metal, and you would like to use that material in different places in your scene on different objects that are using separate light maps. In the old Unity days, before 2.1, you actually had to make several materials. Just you had to make one wood material that references that light map, you had to make another wood material that references that light map, and it really gets a pain in the ass to modify, because then the art team comes in and they think, well, it's a bit too red, maybe it should be a bit more blue, and then they make it a bit more blue, but then there's actually 5 copies of that material, and they have to go into each one, and they'll forget one and won't notice, and then later on you're like, why is it still red? So as of Unity 2.1, there's actually a feature that you are allowed to leave your light map empty. And it is no longer the material, it's no longer the material that gets to decide what light map gets used when rendering an object, but the new feature allows a render component to dictate which light map gets used when rendering a material. So, for instance, if we have stone brick 01, this material, pretty sure it was this one. If I change this one around, you'll see that this material is used, I'm sorry, it's a bit vague, but you'll see the material is used here on the bottom wall, but it's also used on the pillars. Those are two separate objects. We used to have two stone bricks materials, two stone brick 01s, with each one referencing a separate material. Right now we can tell, if we select the, so it's the wall, no, it's the floor object over here. Okay, so the floor game object has a renderer component, and the renderer component actually maintains a light map property. I'm not sure why it's not exposed in the GUI. I'm sure it's just the oversight. It'll probably get included at one point. And this component actually knows what light map should be used for all these materials when rendering this specific object. I should be a bit more precise. Actually, the component does not reference a specific light map instance, but you can assign it a light map index. And then there's a global array of light maps that those indexes index into. For instance, if I show you the FBX from this dungeon, as it got imported, you'll see that my import process actually made another component on top of it that contains all the light map setup. And if you look at that script, oops. Light map setup is in tools. You'll see that the only thing basically it does is on awake, it's going to populate this global or this static array that Unity exposes. It's going to populate it with the values that were stored in the public variable here. And those values are these light map instances that I actually put there by modifying the import process. If we take a look at the way we import FBXs these days, it is called Lightmap Finder. There again, Lightmap Finder, it inherits from Asset Postprocessor, and it also gets a call on Postprocess Model. And what we do is, Unity reads the FBX and generates all these game objects, all these mesh renderer components, and all this other stuff, and it gives it to me. It gives it to me, it gives only the root game object, but from that root game object you can drill down the hierarchy and get everything you want. For each renderer component in that whole hierarchy, I am going to actually look through my file system to see if I can find a light map that has the same name as that object that is being imported. We have a convention that we use the name and then lighting map, because that's the default way 3D Studio Max calls its light maps. The load assets backwards recursively, that is just a small helper function that we made ourselves. What this basically does is when it imports this FBX, it's going to look in this textures folder. I should be a bit more specific. For each mesh renderer component in all these things, for instance these dungeon pillars, it's going to look for a texture that's called Dungeon Pillars Lighting Map anywhere in my assets folder. The actual implementation of that find asset backward thing is that it looks in a textures folder here. Maybe it can find it, then it goes up one folder, looks in the textures folder over there, looks if it can find it there, and it goes up all the way to the top of the tree. And if we actually find one, we do this. This is the most important call. We set the light map index, which is the property of a render component that is not exposed through the GUI, but actually is there, and I think it's even documented. All the light maps we find, I add them to a list, and then I tell each render component, okay, you are going to index light map number 3 in the list. You are going to index number 4. You're going to index number 5. And then at the very end, I add a component to that root game object, and I populate that component with all the light maps that we found. So that is this thing. The import process, when given this game object by Unity, it was looking for all the light maps, looked through it through the whole asset database. It told all these render components, okay, your light map number 3, your light map number 5, and then at the end it added one component to the root game object whose responsibility it is that when it gets an await call, it will set the global Unity light map array to all these things over here. Am I making a bit sense here? Any questions on the light map stuff? Is anyone still with me? I might make it available somewhere, if only like my post-process script is really useful for my specific game, but I don't mind sharing it just so people can see the sort of stuff you could do. But you'll want to write your own that makes sense for your specific game. The main message of what I'm trying to say is I'm trying to show that the kind of automation configuration stuff that you can do by modifying the import process. Yeah, it would. I'll see if I can put something up next to the conference video. You put the script in an editor folder so that it becomes an editor script, and as long as you inherit from asset post-processor, which you do over here, then you sort of have to know, I think it's in the help, that on post-process model will be called if you expect this argument. So it's anytime you import the FBX, and if sometimes you want to do this light mapping stuff, not on all FBXs, but you could actually put a check in here saying, okay, if it's in my environments folder, then I want to do this, and otherwise, for instance, we did that on the animation stuff. That thing only did its thing when the FBX file turned out to be in the animations folder. Anything else on the light maps? All right. Yeah. Well, where would you like the light maps to show up? You mean when I look at a material over here? Like here? Well, the thing is, this material might actually be used by several objects, each using different light maps. So what would we show? I think actually what happens is that the render component will just override anything you have there, but I keep it blank on purpose so that I realize, hey, this property is actually getting auto-filled in by the render component on a per object basis. So you're looking for a way where you could still see the light map over there. Right. I don't think there's really a way to get both. Like either you have 4 separate materials for each different object and each referencing their own light map, or you have one maybe. Well, I think it's just annoying to have 4 materials that all reference wood, because if you want to change the wood texture, then you have to remember to do it on 4 things, or if you want to change the diffuse a bit, you have to remember to do it on 4 things. Yeah? If I look at an object, you mean a game object? So like this thing, or pillars? Would I see the light map? If you look at a game object, Unity is kind enough to put the materials that it uses on display here. These are the same materials, so they don't display the light map that's being used. No, because technically speaking, they don't get filled in. This is just input for the render, I guess, to set up the render settings. But you do see it in the scene view. I'm sorry, could you say that again? No, right now it actually it doesn't have a reference. It has an index, and it also doesn't show the index, which makes it for the talk a bit difficult to see what's going on. But the index is actually there, and I'm sure in a future Unity version we'll actually see it in the GUI as well. Anything else on light maps? Okay, so so that's the story on how we use the to modify the import process to add components and to set up these render components to reference the correct light maps. You can actually do a lot more modifications of the import process. And I'm mainly thinking here about materials. Notice when I started off in the talk with that empty thing, with the empty project, I put the FBX in it, and Unity made this materials folder for me. I hate it when it does that. I always turn it off, because we like to have our own system of organizing our materials. We'll have materials that are specific to this scene. We'll have materials that are specific to all dungeon scenes, but not to the characters. We'll have materials specific to the characters. So we like to have a lot more control over where our materials live and how they get used. So instead of using the default Unity behavior of just generating materials or looking for a material in the materials folder, Unity has another hook. Oh, it does this sometimes when you do it through VMware, I don't know why. I have to click reload a million times. There we go. Okay, so we have material assigner. And material assigner also inherits from postprocessor, but here actually we implement a different hook. The hook is called onAssign material model. It's actually not really nicely named API. It should have been more like onAssign renderer material, but we'll live with it. What it does is when Unity imports your FBX over here, it generates all these game objects, and it also generates renderer components. For instance, if we take the dungeon pillars, it has a mesh renderer component. When Unity generated this, it had to come up with some values for the thing, like should it cast shadows or not cast shadows? What materials should this mesh renderer actually use? Now, Unity usually just does its own thing, but in order to make guys like me happy, they add a hook that offer me the choice to decide what material values these render component settings get populated with. So when Unity imports, it generates this game object, it generates the renderer component, and then for each of these different meshes that exist in this object, it's going to call the hook and it's going to ask me, hey Lucas, I'm about to make this render component. What material do you want me to use? That is what this hook is. So the arguments for that hook are a render component, a material, and the material instance that the hook gets passed is the material as Unity read it from the FBX file. Now we don't have a lot of useful settings in that material. Either I don't get it or I'm not a big fan of how FBXs deal with materials. But what we do is we only use the name of the material that was used in the FBX file, and all the other settings in that material, we just throw it away. So all our materials are managed inside of Unity, and we only use 3D Studio Max to dictate what material gets assigned to what mesh. And that, excuse me, that happens on a name basis. Okay, so what we do, I do a bit of logging because this it's always a pain in the ass to figure out what's wrong. I check for some stuff that shouldn't be in the file name, and then I do the same load asset backwards recursively thing. I'm using system.io to actually go through the file system of my asset database to see if I have a material somewhere that has the name of the material as it was stored inside the FBX file. So what that does is if I import this, it will look for a material in the materials folder here. If it happens to not find that, it goes up one folder and it looks for the material right here. If it cannot find it over there, it goes up one folder again. So basically the hook allows me to have my own sort of management system of what materials go where, and for Unity to nicely hook into that. And we like that better than of course the alternative would be to just in Unity drag materials onto instances of those FBX things. That's I guess what the default Unity way is. But if you start dealing with the amount of content that we want to put in this game, we don't want to do all that stuff in Unity because it's already done in Max. When the art guys design a scene in Max, they already have assigned materials to it because they need to make light maps and everything. So we don't want them to redo that in Unity. We want to reuse the information already present in that FBX file. So that's why we use the import asset pipeline modification to actually get that done. So what we do, if we can actually find the thing, we return it. And if we don't find it, I should display it like this. So maybe for some materials, we didn't find it. For instance, if I rename this stone brick material to like underscore, and I re-import this thing, it won't be able to find the material, I hope. And then it will actually use unmapped material that has, usually it's bright pink, but I guess somebody changed it these days to like blue bars. We use this to indicate to artists that they import an FBX file, but some of the materials are not resolving to the materials already in the Unity project. So then we assign it like this bright pink that now happens to be not bright pink. And you can actually do a lot more comfortable stuff for your art team there. As Unity imports this FBX, it goes through all these render components, and for each element of the render component, for each material that it wants to use, it calls your hook, and then when it's all done, you get another hook. You can respond to on post-process all assets. So what we do is, as Unity is continuously asking us what material to use, For the ones that are not resolving to a material, we just remember. I add them to the list, and when the whole FBX is done importing, I show the dialog that you saw came up. It says, there's a missing material. This is the name of the missing material, and these are the objects that are using the material. So that's already, it's sort of a in-your-face reminder if people might happen to overlook the bright pink or pretend they don't see it. But as the author of your import pipeline, you can actually facilitate your RT more. You could actually generate these materials on the fly for your art guys. Let's take a look at how that looks. If I, for instance, say, please generate them for me. It reminds me I need to re-import. You'll see that the Stonebrick 01 that was unresolved, because I put an underscore here to the real one, that it got automatically generated here. You can also see that it actually already populated the diffuse texture. So when we auto-generate materials on request of the artist putting in assets, what we do is we use that same trick to use system I/O to iterate through your file system to look for textures that might want to be used. For instance, let me check. This is a function called auto-generate material. As Unity asks us, hey, what material do you want to use? We don't only remember the names of the materials that don't resolve, we also remember the names of the objects that use them. So as we use the Unity API here, no, I should say that a bit differently. I will create the materials folder if it's not there yet. That's all blah, blah, blah. Then I will actually look through the file system and see if I can find a texture that has the same name as the material that we were looking for, because that is probably the texture that the artist wants to use for this material. So I check, I'm looking for a texture that actually has the name of the material, and then we also look for a texture with underscore diffuse map, and that's sort of a convention thing. You could add like regular diffuse map. We look for that, and we remember if it's there or not. Then we look for a texture with the same name as the material that we weren't able to find, postfix with normal map. See if we can find that. And then for each object that was using the material that we were unable to find, we look if there is a light map texture that has the name of that object with the postfix of lighting map or light map or whatever 3D Max calls those things. And then based on all that information, you as a pipeline author, you can actually make a very good guess on what kind of material you think the artist wants to use here. For instance, if you find a diffuse map and you find a normal map, then he probably wants a bump specular shader. If you only find a diffuse map and a light map, then you probably want a light map shader. We actually also check if the diffuse texture actually has an alpha channel. If it has an alpha channel, you probably want to use a transparent shader. If it doesn't have an alpha channel, you might want to use something else. How that works is very game specific. Right now in this stuff I prepared for the talk, we actually do, if the diffuse map is transparent and we have a light map, I use this shader. If the diffuse map is not transparent and we have a light map, then we use that. And you can actually tweak this for your specific game. If you make a game, you probably have like 6, 7, 8, 9, I don't know how many shaders that you actually use on a day-to-day basis, and you can you can modify you can make a really good guess based on the textures already present in your assets library on what material you can auto-generate. And then the moment supreme, we use the editor tools that create assets. Oh, actually, that's a function of me, I think. Notice how with Visual Studio, you can just right-click and say go to definition, and you go there. Oh, that's a useful wrapper. So we call asset database.create asset, and the material that we just automatically generate, we actually write it back to the asset database so that it actually appears over here. And unfortunately, we cannot actually assign that material right away, so we need to re-import it for it to show up. And you can actually see that all the nice talk I do about the auto selection of the right shader is actually not working all that well for our game because we use a different shader, but that's sort of, it uses the wrong shader now, but that's sort of beside the point. If I go to the gradient Macade shader, there we go. All right, any questions about all this material stuff? All right, is anybody still with me? Nice. Sure?
I have a question about, I'm not familiar with Unity yet, so I'm just wondering how come you had to sort of have a naming convention in order to find the right texture file for a given material in FBX?
Oh, you mean why look for a naming convention? Why don't I just grab that information from the FBX, from the material that was stored in the FBX? Basically because, like for the diffuse I could, but for normal maps and for light maps that gets problematic because either those are not stored in the FBX or I don't know how to get them out, and I certainly know that our art team doesn't know how to put them in.
Wouldn't it be cleaner to say like the file name for the material in the FBX points to the diffuse texture, and then you have postfixes for the other like normal map and stuff like that.
That's actually what we do. We look for a diffuse map with the same name as the material, but since I'm such a friendly programmer and I like to service the art team, I also look for a diffuse map. Just like with normal map, I look for a name called normal map, but I also look for _ normal map, just because the art team, one day they'll do it with this underscore, the next day they'll do it without an underscore, and I don't want them calling me all the time, so I just make sure that the code works both ways. Any other questions? About material stuff or anything? Yeah, it is.
You showed earlier the animations that you wrote your own component. You store the animation inside your component, and you store the value, how much distance the character has to move.
Correct.
And you told that when you work inside Unity, you drag that component around all the time. Can you show the character prefab? Like, do you populate it by code, the animation bank? Like if a character has 50 animations, where do you get it from? Do you actually drag the animations there?
Okay, that is a good question that I've been bothering Joe about all conference. Do you hear that, Joe? Somebody else is wondering as well. Yeah, we get so many animations in the this is a list of animations, and it's only for the guy, and this is only with like 1 or 2 weapons yet. We actually use more import pipeline modifications on the post-process assets. I have a thing called the asset list over here, the autogen asset list. And this is a scriptable object. Look up scriptable objects in the help. It's extremely useful, very much not often used feature of Unity. And the import process actually generates this file automatically based on the content of a folder. And it puts all these references in so that I can actually look up a animation by name instead of having to tell the art team, well, look, there's like these 200 animations here, and you have to like drag them to this component, and you cannot forget one. Does that sort of answer your question? And we have like script components that use that instead of asking for an animation clip, they just have a public variable called animation clip wrapper, and we drag the wrapper on instead, and then we get to the actual animation clip through that reference. But actually, we don't. We're a bit unusual Unity users, I guess, because we don't use the dragging stuff all too much. We use these asset lists and then refer to those things by name. That's sort of our current workflow that we like best. Any questions, yeah? John?
Have you figured out any hack to make it up? VM contents, the actual VM file.
Okay.
And inside you have the application, so you take it out anywhere on your desktop or whatever. And you tell Unity, this is my scripted file.
Okay, so apparently there's an even more tighter integration of Visual Studio and Unity possible. My work setup is actually using 2 different computers. So I haven't gotten around to. I just try to not make exceptions. Oh, one more. Actually, 2 more comments. This is Miguel. If you would like a debugger, talk to Miguel. Miguel, you're in a room of 150 blindfolded programmers who need some love. Yeah.
The thing is that I'm a Linux user. And Linus Torvalds used to say that if you need a debugger, you should be writing code. But we'll get you. We're on it. The debugger.
Yeah. And another comment. We actually, I've been getting some emails about the way we use Subversion to version all our projects instead of the asset server. And I didn't want to do a large part of the talk on that because if you're not interested in that, it's extremely boring. But since so many people were interested in it, I'll put my name on the hands-on thing. And if you're interested in using Subversion, just put your name on it, and we'll get together with the people who care about it, and we can talk about how you can get it to work, although it comes with a great deal of pain as well. Any other questions?
I just want to go a bit further on the animation imports. You can actually access the animation clip curve data. So for example, I believe you could find the distance of your watch just by looking at the curve.
Right. Yeah, I think we could. Although it might be a bit difficult because you probably want to. The question was the metadata we use for the animation, the distance stuff. That you could actually extract that from looking at the actual animation data, how much the pelvis moves. But for instance, the girl sort of walks like this, and her hips go forward and backwards. So you actually might miss a bit. And if I would tell my art team that, they'd just say, no way, we want to tell it exactly how far it moves. But that is a cool trick, actually. Okay, I will get into a fight with Tom if I don't stop talking. If you have any more questions, just feel free to contact me or to walk up. And thank you for listening.